And hello, hi, and howdy, one and all. Here we go with Chapter 12, Lesson 7. I'm going to call it Lesson 7a. I will graph linear equations. That's our target. That's the title, Graphing Linear Equations. Go ahead and pause your video. Come on back when you're ready. So as you can see from previous days, from the previous lesson, we learned how to take an equation, come up with some input values, some x values, substitute those numbers into the equation, and find out what is the y value that is needed to make a true statement. So every one of these ordered pairs, for instance, -3, 9, -2, 6, if x is 1, y must be 3. That's what it takes to make a true statement. Therefore, those are solutions, right? So what we're going to do is we're going to continue that today and then use it to actually graph out a set of all the possible solutions. Well, wait a second, Mr. Cowan. Just because our table stops doesn't mean that the numbers do. We could have used 2 or 3 or 3 trillion or -1.5 and -1 3/4 and -1.9 and -1.99 and -1. So the point here is I want you to think about how many solutions are there to a linear equation, and therefore how would we graph them? Keep that question in mind, right? All right, so here we go. This is called a T-chart. It's an abbreviated table so that you don't have to show work. I bet you won't be surprised at the x or input values that Mr. Callan chooses. I'm going to start with 0. And then if you got to choose another couple, I'm going to go with 1, and I'm going to go with -1. So why make it more complicated than it needs to be, right? Now remember that we're going to take each of these input values and we're going to substitute them in for the x. So for instance, let's start with 0 because heck, 0 is always one nice number to compute. -2 times 0, of course, is 0. So when x is 0, y is 0, and we can now take a point and plot it right on the graph. All right, so let's go ahead and start with 1 now. So let's substitute in 1. In other words, when x is 1, what must y be to make a true statement? I feel like I'm going to sneeze. I tried to mute my microphone, but hey, we'll see what happens. All right, I think I got it. There we go. Okay, so -2 times 1 is -2. Therefore, to make a true statement, when x is 1, y must be -2. And so we can now plot the point when x is 1. So we go 1 to the right, -2 down. We're down in the 4th quadrant. And let's wrap it up, please. Let's go with substituting in a -1. When x is -1, -2 times -1, the opposite of a negative would be a positive. So when x is -1, y must be +2. So we go 1 to the left, +2 goes up. And I bet you're seeing here, well, let me not say anything just yet. Just a reminder that just because we stop at 1 doesn't mean there's no more solutions, right? We could go 1.5, we could go 1 3/4, we could go 2, we could go 3, we could go 3 trillion. And the sooner or later you start to see, we could actually pick up infinitely many numbers in between of 0 and -1, right? You could put in 1/2, you could put in 3/4, you could put in 1/4, you could put in 0.002. And so we start to see that there are billions and billions and billions and billions and, well, you get the idea, right? Therefore, because there's infinitely many solutions, we don't want to sit here and draw trillions of dots all the time. But now look, and perhaps you see why we called this graphing a linear equation. Because if you truly graph out all the points, well, would you look at that? They make a straight line. Whoops. That, ladies and gents, is why we call it graphing a linear equation, because all the solutions of this line, all the solutions of this equation will form together to make a line. One last thing I'd like us to do, and that is to put a star on the y-intercept. Where does that line cross the y-axis? Boom. Okay, so that point is 0, 0. Now, some of you might already know where we're going with this, but I want you to keep in mind as you look at this equation, as you look at the table, as you look at the graph, is there a connection with the y-intercept, where the line intercepts or crosses the y-axis? Keep that in mind. Please, here we go. Aha, well, wait a second. While 0 is going to be quite nice, you might not choose to use 1 and -1 this time. In fact, if you recall from the previous lesson, there will be other nice points that you might choose to use as we examine this equation. Y is equal to 1/2 of x minus 2. Now let's go ahead and just substitute in the 0, of course. So when x is 0, half of 0, of course, is 0, and 0 going down 2 would be -2. So the only y value that'll make a true statement for this, therefore the only ordered pair that makes a solution when x is 0, y must be -2. We'll go ahead and plot that point, and we'll keep on going. Now again, could I sit here and substitute in 1? Absolutely, but let's go with 2. And think about why that'd be nice. Half of 2 is 1. And what's 1 go down 2? Oh, well, that would be -1, Mr. Cowan. So when x is 2, y is -1. And just for kicks, sorry, I didn't put a negative sign there. Let's go with -2, shall we? Let's substitute in the opposite of 2. So what is half of -2? That'd be -1. -1 go down 2. You may change that into adding the opposite if you wish. Some of you like to do that. The only number that will make a solution here, when x is -2, y must be -3. Now, if you're wondering, why did I skip the 1s? Well, it's not that 1s are impossible. They're just a little more challenging because of the fractional coefficient. So think about it. What is 1/2 of 1? That'd be half. So you're going to go up a half and you're going to go down 2. Change that to add the opposite if you wish. And you will get a number. It's not that the number doesn't exist. It's just, a little ugly. Oh, I graphed that point wrong. How about that? Can I go back? I want to make that mistake. All right, I want to make that mistake. I want to look at this and I want to say, how can I graph a line through the points if they look like, wait a second, that doesn't work, does it? Now perhaps, ladies and gents, you can identify why we choose to use 3 points at all times, okay? Wait, let me get rid of that. So the reason we use 3 points is it should always make a straight line for a linear equation at least. And if we don't notice a straight line, then one or more of those points is messed up. If you only use 2 points, let's say I did these 2 points first, I would draw a line and never know. I would never know that it's wrong because I only did 2 points. So do at least 3, although frankly I like 4. Then let me come back here and properly graph -2 to the left, -3 down. Well, look at that. It sure looks like a straight line. And I'm going to draw my graph all the way through and then make sure I draw the arrows. After all, just because my table stops, just because the coordinate plane seems to, it doesn't really stop though, does it? It goes on forever and ever. So again, to come back here, sorry for that mistake, when x was +1, y is -1.5. Does that fit? +1 to the right, -1, yeah, it works. It just is a little tougher when you have fractional coefficients. So I want to be very clear here that there would be nothing wrong with using the x-coordinate +1 and the y-coordinate -1. If we substitute in -1, we get -1/2. Go down to, would be -2.5. Where is -2.5? Right here on the line. So it's all right. But I believe you could do yourself a little bit of a favor and identify a little nicer x-coordinates when the coefficient is a fractional coefficient. Otherwise, I'm going to use -1, 0, and 1 all the time. Oh, let's put the star in for the y-intercept. Where does that line intercept the y? Boom! Okay, so the point 0, -2, I'm wondering if you're starting to see a pattern with the y-intercept. I'm wondering if you're seeing that y-intercept or a pattern with the equation that tells you what the y-intercept is. I'm wondering if you can see on the table something about the y-intercept. So I'm just planting a seed. Keep it going. And here we go. Let's do one more of substituting an x, and instead of 1, I tell you what, I'm not even going to use 2. I'm going to use 3 here. Why, you might ask? Well, take a look at that fractional coefficient and what will make our lives a lot easier. In fact, let's go in the negative direction and use -3 as well. So we're going to substitute in 0. Why? Because 2/3 of 0 is 0, and the opposite of 0, actually, there is no opposite of 0. 0 plus 1, the only number that'll make a true statement when x is 0, y must be 1. And so we go ahead and we graph that out. And let's carry on, please. Why did Mr. Callan choose -3? Well, if I come off to the side here, some of you can mentally compute -3. Others of you will put a 1 here. You'll cross-reduce the 3's, and you'll get 2 wholes times 1 whole. So that's 2. Oh, and the opposite of a negative is a +2. +2 plus 1 is a +3. So the only y value that would make a true statement is +3. Now, if you need to rewind, go back and look at that computation again. 2/3 of 3 is 2. The opposite of a negative is a +2. And then 2 plus 1 is 3. So starting at the origin, -3 goes to the left, +3 goes up, and we have another point. Onward we go. Let's try the +3 now. Now, we already said that 2/3 of 3 is 2, but the opposite of that positive would be a -2. Now, -2 plus 1, think about -2 plus 1. There's a 0 pair, cancels out. What does that leave us with? That leaves us with -1. So when x is 3, the y value must be -1 to make a true statement. Now I'll start at the origin. +3 goes to the right, -1 goes down. Does it appear that those 3 points make a line? Sure. Could I have used 1 and 2? The answer is yes. Could I have used -1 and -2? Sure. But as you can see, when we substitute in x values that are multiples of that denominator, they will cross-cancel. So I could have used 6 because that would cross-cancel quite nicely to make 4. I guess it would have made a -4, huh? So beware and use proper x or input values. Let me go ahead and grab my ruler and let's draw a line through this. And I'm going to cap that line with some arrowheads after all, just because our table seems to stop, just because our coordinate plane seems to stop. In fact, this would go on and on and on and on. Let's find that y-intercept, shall we? I'm going to take a star, put a big old star right at that y-intercept. What is that point? 0, 1. Now at this point, I hope you're seeing a pattern with the table and the equation. Going backwards, I hope you're seeing a pattern with the table and the equation. Going backwards, I hope you're seeing a pattern with the table and with that equation. Just because you don't see it doesn't mean it's not there. And so, folks, that's the notes for today. I should have mentioned that those notes were, in fact, a Kami file that you could have written. Homework assignment for today will be not May 3rd. This is going to be for the 27th and the 28th, okay? So I'm going to make this due on the 28th because you shouldn't really have homework on an iLearn day. Virtual only students, quarantine students, you of course can get this all done today. Page 349, numbers 9 to 20, I have included in Google Classroom, I have included some graph paper. And there's the notes. Here's the graph paper. So you can use that graph paper to complete this assignment. Take care, folks. Do well, and let's grow.